So last time we talked about what the whole point of this class was, the whole mission of statistics. So somebody remind us what that was. What's the whole point of statistics? Yeah.
To represent a population in a sample and then apply the findings of the sample to the population.
Yeah, excellent. So there's some information we want to know about all the data points in the population. And the population is everything that we're interested in, like the whole country, or it can be the whole state, or it can be all Facebook users, for example. Whatever it is we're interested in knowing about, that's our population. But we said that often it was not feasible to know things about the entire population, and we calculated that it would take, for example, on the order of thousands of years in order to call every single American, for example. So because of that, ultimately we're going to be limited to only a subset of the population, or the sample. So from the sample, we want to be able to make a conclusion about the entire population. And so this is the whole purpose of statistics, is to make this inference about the original population using the sample. So it's inferring a conclusion about the population using the sample. And then last time we elaborated on each step a little bit, and we said that if we were to trust the sample to make conclusions about the population, then there's some properties about the sample that has to be true. So what did we say had to be true about the population, or about the sample collected from the population?
It had to be representative of the population.
Okay, very good. So it had to be, one criteria was that it had to be representative of the population. That means that all the important attributes have to be represented in the same proportion in this sample that we collect as in the original population. But practically speaking, how do we ensure that, or how do we go about achieving this representation? Yeah? Yeah, good. So we can't cherry pick every single important attribute to make sure that it's represented in the same proportion. But instead, we're going to try to make the sample as random as possible. And last time we said that that meant that we wanted the sample to not have any biases, including volunteer bias. But practically speaking, oftentimes it's very hard not to have at least one kind of bias, like volunteer bias. So our goal is to minimize the amount of bias as much as possible when we're collecting the sample. So what was the second attribute of a good sample? Yeah.
The right size.
Yeah, so the sample size is important. So we said that we wanted a sample size that was large enough to be accurate in making a conclusion about the population, but still small enough to collect. And so this is an issue we said that we would talk about later in the semester. This issue of being random and representative of the population, this is just as important as the sample size, if not more important. But this is something that we've already talked about in full, in detail. So this is something that we don't need to talk about later. But we will talk about the sample size that's needed later. And then so using this good sample, we're gonna analyze the sample first and try to organize it and clean it up before we start using statistics to make the inference. So this is what we'll talk about in the next class. This is organizing the data in the sample and summarizing the data. So this will be in the form of charts and graphs and different measurements, like finding the average and the mean and the median, the standard deviation, and all of that. So analyzing just the sample itself. And then from there, we're gonna talk about, later in the semester, we'll talk about how to use that sample based on the organizing, summarizing that we did to infer a conclusion about the whole population using the sample. So just as a roadmap, we're gonna be spending some time analyzing the sample, and also we're gonna be spending some time building up the framework and the tools that we need in order to go from this step to this step. So a large part of the semester is ramping up and finding our legs and building the framework to actually get here. So that's just a heads up as to what we're gonna do, because there's gonna be a point in the semester where you're gonna feel like you're kind of lost in the weeds. Like, what is the point of being trapped in these big weeds right now? But the point is that we're building up this framework in order to ultimately get here. Because if we just jump here, then we're not gonna have the tools that we need yet. Okay, so after we build up this framework in order to start actually getting into the inference of statistics, then after we use the statistics itself, we're gonna have to communicate our results. And we have to communicate in a way that is accurate. And even though this sounds like just the icing on the cake, kind of trivial relative to everything else, this is just as important as all the other pieces. So we're gonna spend some time now, today in the overview, talking more about this part. And one of the important issues in communicating the results is there's this issue involved in communication called the correlation versus causation fallacy. Or for now, I'll just say correlation versus causation. And so let me illustrate this with an example. Let's say that in your next job, let's say that you work for a news agency, and that news agency happens to notice that around a certain area, a certain town, for example, and around a certain time, there happens to be an increased amount of drowning incidents. So more people are drowning, for example. And so let's say that around the same time and same place, you also notice that more people are buying ice cream, so increased ice cream sales. So those two things seem to be happening together. More drowning, more ice cream, more people eating ice cream. So can you conclude that one is causing the other? Can you conclude that eating ice cream is causing people to drown? No, that's ridiculous, right? So it turns out that those two things happening together, that's what we call correlation. So correlation is two things that are happening together, but just because there's correlation doesn't mean that one is causing the other. Doesn't mean that there's causation. And in this ridiculous example, it's very obvious that those two are not the same thing and shouldn't be confused. But it turns out that in real life, those two things are confused all the time. So this is an issue of correlation versus causation. So, for example, and something more important, like let's say that there's this drug that is supposed to lower cholesterol, for example. And so let's say that you happen to notice that people who take a drug, let's say they seem to have lower cholesterol than everybody else. So what's very tempting to do is to say that that drug is actually causing the lowered cholesterol. That may or may not be true, but that's an example of two things that are happening together. That's an example of correlation. You can't just say that because there's correlation, there's also causation. And so this distinction is very important. So we're gonna go through some important examples together to try to get you to practice telling the difference between the two. And not only that, but when can we actually tell whether there's causation? So we'll talk more about that too. So for example, this is something that I read in the news a few years back, which is there's some researchers who were trying to answer a certain question about whether or not college students who travel are more creative than students who don't travel? So this is the question they're trying to answer. And let's say that the researchers conduct their study so that they look at two different groups of college students. Let's say there's 100 students in each group. One group is known to have traveled internationally. And one group did not travel internationally. And let's say that the researchers gave each group of students a test that was designed to measure creativity. And so let's say that there's a threshold to this creativity test where if you score above a certain amount, you're deemed creative. And if you score below a certain amount, you're deemed not creative. So let's say that the researchers gave this group of students who traveled internationally this creativity test, and let's say that out of 100, 52 were deemed creative. And the students who didn't travel, let's say, are deemed creative. So then, what the researchers did was they noticed that between these two samples of students, one sample traveled internationally, not internally, internationally. One group of students traveled internationally, another group didn't travel internationally, and the group who traveled internationally seemed to be more creative than the group who didn't, and they were more creative by a factor of how much? How many times more creative was this group who traveled internationally compared to the group who didn't? 4 times. So it seems like there's a 4-fold difference in creativity among the students who travel internationally. But this is only between the samples. So then what the researchers did is they used statistics to infer whether or not there's the same difference in the populations of students who traveled internationally versus didn't travel internationally. And let's say that after using statistics, the researchers concluded that this is not just a fluke, that in the populations, if you look at everybody in the world who travels, all the college students in the world who travel internationally, it's also a 4-fold difference in creativity among the students who didn't travel internationally. So this result carries to the populations as well, and not just limited to this samples of 100 each. So that said, then what the researchers did is that they said that they published the results, and they said that students who traveled internationally are more creative than students who didn't travel internationally, and they said that there was a causation associated with that because there could be no other explanation to explain this data. So the only way to explain this data was that students who travel internationally are more creative than students who don't travel. So this actually happened. So what are your, this was actually published, so what are your responses to this? Do you think this is true? Based on this study, these results, do you think it's true to make this conclusion? Yeah, so what do you think?
No, there's a lot of extenuating circumstances and factors that are not being told to us that could very much affect socioeconomic situation, upbringing, where they live, first of all.
So that's absolutely correct, but based on this results that was reported, and assuming that their methodology is correct, and you could argue that there are a lot of holes here. You could argue that this creativity test to begin with could be flawed because what test accurately measures creativity? You could argue that. But let's say that based on what's being reported here, that everything reported is correct.
Then yes.
So let's say that this creativity test is correct, and let's say that there's actually a fourfold creativity difference between this group who travels internationally versus the group who doesn't travel internationally. So what conclusion or what result could explain these results? And do you think that it's true that the only explanation that could explain these results is that students who travel internationally are more creative than students who don't? Like the researchers are claiming.
I mean, I agree with it if their test on creativity is based off like that study. Like if they're basing off their creativity on that study and it's moved towards that, then yeah, it'd be 4 times more creative.
Okay, but so do you think that the 4 times more creative is being caused by the traveling, or do you think it's just a correlation? Do you think they just happen to be happening together? Or can you definitively say that this 4 times more creative is being caused by, or is a result of the traveling internationally as a whole? So this is what the researchers want you to think,
Yeah.
but what do you guys think? Yeah.
I personally think that yes, because traveling internationally in general just opens you up to so many new experiences that you would just not see at home.
Right, and that's what these researchers are trying to convince you of, but just by this data alone, do you think that you can decisively, definitively make that conclusion?
I'd say
Yeah,
I'd say no, considering, we don't know how many samples they've had. If this is just one sample that they've tested, and this is the one time they got this result, then how can we say that it's accurate? They could have just gotten a specific amount of students that were more creative than the other.
Okay, very good. So this is based on just the samples of 100 each, but then the researchers are trying to convince you that this extrapolates to not just the samples of 100, but to the general populations at large by doing the statistics and saying, based on the results of the statistics, they're saying that this 4-fold difference applies not only to these samples, but it's applying to the populations of all students who travel internationally versus not traveling internationally. So if you look at all the college students in the world who travel internationally, the statistics is telling us that there's a 4-fold difference in creativity compared to all the students who don't travel internationally in the world. So even so, can we conclude that this 4-fold difference in creativity is caused by the travel?
But what about like the other 42 kids who traveled internationally? The other 48, does the correlation not match up to them? Like,
Yeah, so over here, so you're saying there's 48 who are not creative. But you could argue that what's left over is that over here, there's 87 that are not creative over here. So there's also a lot more students who are not creative by not traveling. So you could possibly argue that. And so, but what the researchers are arguing that as a whole, there seems to be a much greater difference in creativity in the students who are traveling internationally, and there seem to be a lot more students who are creative by traveling internationally, and they're trying to argue that that difference is caused by the actual traveling itself, because that's the only difference that seems to be taking place here. So that must be what's causing the traveling. That must be what's causing the creativity difference, the traveling itself. So again, do you guys think that that's true? And if it's not true, then what other narrative can you make that also explains this data? That there's a 4-fold difference, but it's caused by something else, and not the traveling itself.
Well, I agree with it because, I mean, personally, I think people that travel and stuff, they experience more cultures and they have a better understanding of what's going on around them in their country, per se, like world as well. People that are stuck in their bubble and they don't travel or whatever, they probably have no idea of the possibility of like what they could be thinking going on in the world.
Right?
So, I mean, I would agree with the study. I just think it's a small study.
Okay, so that conclusion makes sense, but the question is whether that conclusion is the only conclusion that can be made from these results, or is there an alternative conclusion that could also be applied that explains these results? Yeah.
typically those who travel internationally have a lot more money and therefore resources to try more things. I'd say that those who travel internationally would be able to indulge in more creative hobbies than those who can't travel internationally.
Okay, excellent. So the whole reason why the researchers quote got away with saying that traveling is actually leading to the creativity or causing creativity is that they're trying to convince us that that explanation is the only one that can explain this data, that traveling itself is leading to higher creativity. But it turns out that you could have an alternative explanation that explains this data just as well. For example, you could say that students who are creative to begin with, maybe they just like to travel. So you could actually argue that creativity is actually leading to the traveling. So basically, the converse of the situation. So now we have two competing explanations, and we don't know which one is correct, so we can't just assume that one is correct over the other. We would, at this point, have to test each one individually and see which is actually the correct explanation. So, aside from these two competing explanations, there's actually another one, which was just brought up, which is these two groups, one who travels internationally versus one that doesn't. These two groups at the surface look like the only difference seemed to be traveling versus no traveling. But as a whole, it turns out that there are many other differences. So for example, what was just brought up is that students who travel internationally as a whole, would you agree, have more money than students who don't travel internationally? Yes, so as a whole, we can say that this group has more money. So maybe, just speculating, maybe that this group who travels internationally, because they have more money, maybe that more money also afforded them more educational opportunities throughout their lives. And maybe that is leading to the higher creativity and not just the act of traveling itself. So this extra thing that's associated with this group, this is something that we call a lurking variable. So lurking means hiding out. And maybe this lurking variable is the thing that is leading to the change in the output, which is the creativity difference. So another competing explanation that we can come up with is that traveling is associated with more money, and associated with, I'll just put maybe a double colon here. Traveling is associated with money, and that money is leading to educational opportunities, which is leading to more creativity. And it's not just the traveling itself. So this is an example of a lurking variable that is actually causing this change in output, or causing this change in creativity. What's another example of a lurking variable that you can think of? Something that's tied to this group that travels internationally that in itself is actually leading to higher creativity. So as a whole, college students who travel internationally also have more what that maybe is leading to higher creativity.
Drive to travel.
Yeah, maybe they.
This group just doesn't want to travel, and they just picked 100 people that just not a lot of them want to travel.
Yeah, so maybe students who travel internationally have the motivation to travel, and maybe that motivation to travel is tied to more creativity. Maybe. Good. So what else might be a lurking variable? So what we're doing here is we're trying to, as practice, we're trying to identify lurking variables, which are things that are tied to this group who travel internationally. And those things in themselves are actually leading to more higher creativity and not just the fact that they travel. Like having more money. Yeah.
Maybe they come from a cultural diverse household or something, like family.
Yeah, so maybe students who travel internationally are exposed to more cultures and more perspectives, and because of that, they're more creative, and not just the act of traveling itself. Okay, good, maybe that. So what else? What else might be a lurking variable?
Like more free time, they don't have a job, they don't have a lot of social obligation at that time, or just in general.
Okay, excellent. So maybe students who travel internationally, we could all agree as a whole, they have more free time, for example. And that free time maybe is freeing their mind from obligations and allowing them to be more creative. So that very well could be an explanation. We're not saying that it's necessarily true, we're saying that it's an alternative explanation that explains this data. And to find out which explanation is true, we would have to test each one. So attached to this group who travels internationally, another lurking variable could be more time. And maybe traveling is linked to more time. And that's freeing up their mind, and that's allowing them to be more creative. Okay, very good. So the point is now that we have at least one alternative explanation that explains this data. So we have 4 explanations now. So we don't know which one is actually correct. The researchers tried to hoodwink us and say that this was the one possible explanation, so therefore it must be true. That's not the case. So because of all these competing explanations, we can't assume one is true, and so the best we can do is say that traveling and creativity are increasing together. The best we can say is that there's correlation. We can't necessarily say that traveling is causing creativity. The best we can say, in this case, is that traveling is connected with creativity or correlated with creativity. So, the best we can say is that traveling is correlated with creativity, and not that traveling causes creativity or leads to creativity. So even though this is the correct explanation, the correct conclusion for these results, it's not necessarily an interesting conclusion, because correlated just means that they're linked. But it doesn't say at all whether the link is strong or the link is weak. Versus when you say that there's causation, the link is definitely strong. One is directly affecting the other. So that said, how would we be able to conclude whether there's causation or not? How do you think? So the best we can say in this case is that there's correlation, but how would we be able to conclude whether or not there's causation?
I mean, you would have to look at their creativity before they travel and then after they travel to see if there's a difference.
Okay, excellent. So the only reason in this study we weren't able to conclude causation is because the difference between these two groups, at the surface, it looks like there's only the difference in one thing, which is traveling or not. But if you look deeper down, you'll see that between these two groups of students, there's actually many differences, and not just whether there's traveling or not. So the other differences are in these lurking variables. The group who travels also differs in having more money, they differ in having more time, and lots of other things as well. And any one of those things could be causing the difference in creativity, and not just the traveling itself. So because we have all these lurking variables, all these differences between the two groups, if there's only one difference between the two groups, and there's a difference in creativity, then you can say that that difference in creativity is because of the one difference between the two groups. So now we have to conduct our study in a way that between these two groups, there's only one difference in traveling or not. And so somehow we're gonna have to eliminate all these lurking variables somehow. So one way to do that is what was just suggested, which is
Having them travel.
having the same students but doing it before and after. So that the only difference between the two groups is traveling or not traveling because of the same students. So this is what we call a longitudinal study. So longitudinal means over time. So basically we're going to do a sample of some number of students, and then we're going to do a before, where we test those students for creativity, let's say 100 students. And then we test them for creativity. And then we're going to send them off to travel. And let's say that that's the after. And then we test them again. And then only if the difference between the two test results is markedly different so if that's the case, we can say that that difference has to be because of the one difference between the two groups, which is because they travel. And this is what we call a longitudinal test. So there's actually another way in which we can try to determine whether there's causation. Any suggestions on another way in which we can devise a study that has two groups, but they're the same in everything as a whole, except for the fact that there's traveling in one group and not traveling in a different group. So instead of having the same students, and before and after, yeah.
Having like a control group?
Yeah, very good. So this is what we call a controlled study. And instead of having the same students before and after, what we do is we have a random group of students. And then we test them for creativity. And the second group, instead of having the same random group as before, we have a different random group. But as a whole, they're the same, or they're similar. Because whatever percentage of types of people you have in the first group, like a certain percentage will have a lot of money, for example. So in the second group that is random, it'll have roughly the same percentage of types of people. It'll have the same percentage of people who has money, for example. So this will be a second random group. But now, instead of testing them directly, you're going to send them off to travel. And then you're going to hope that they come back. And after they come back, you're going to test them again. So now you can compare these two test results. And again, if the test results of the group who traveled is much higher than the test results of the group who didn't travel, you can conclude that this output, this difference in output must be because of the one difference in the two groups as a whole, which is the traveling aspect. And so this is the second way that people determine whether there's causation. So there's two ways that people measure causation. One is the longitudinal study before and after of the same group. And the second way is take two different random groups, and the only difference is the traveling aspect. And if there's a difference in creativity, you can conclude that it must be because of the creativity. It must be because of the traveling aspect. Okay, any questions? Okay, so this study that was actually published, these were done by real professional researchers who know the difference between correlation and causation. But why do you think that they conducted the study this way versus conducting the study in one of these two ways that are known to measure causation.
Ease of research.
Yeah, why is the way they did it easier than one of these two ways?
Well, because they already have a preset group that has the dynamics that they're looking for already. They don't have to pay for any travel for anyone. They don't have to wait for people to travel. And it just comes pre-ready for them to research.
Okay, excellent. So it turns out that this way is much easier. And the reason for that is to gather these two groups of students, one who traveled internationally, one who didn't. It's very easy to do. So everybody who walks by, they can just ask, hey, have you traveled internationally? If that student did, then they're just lumped in this group. If they didn't travel internationally, they're just lumped in this group. So in minutes or a matter of hours, you can form these two groups, and then you just give them tests and score the test right there, and then you can finish that study in an afternoon. Versus over here, one of these two studies, what do you have to do? You have both, in the longitudinal study, you have to collect a random sample. So this group here is random. And we talked about the particulars of trying to gather a random sample. We said that that's actually quite difficult. To make sure that that sample is completely random is actually difficult in itself. And then not only that, but now after you collect the random sample, you have to test, and then you have to send that sample off to travel. That's the after. Which means that you have to pay for them to travel, and then you have to wait a certain amount of time for them to garner any skills, like any creativity differences, wait for months, and then hope that they come back, and then test them again. So you have to pay for them to travel, and then wait for them to come back. Same thing over here with this control study, basically the same thing. You have to gather two different control groups, and then test one, and then wait for the other one to travel and come back. So, because of this difference, the first type of study is called an observational study, because all you're doing is observing what has already happened before. So they've already traveled in the past, so you're just observing what they're like now. So this is an observational study. This is also called a passive study. Versus this causation study, this is called an experimental study because you're actually conducting an experiment. You're actually sending them off to travel and waiting for them to come back. So this is called an experimental study. Also called an active study. So there's a big difference between the way that these studies are being conducted. So if you have a passive or observational study, the best conclusion that you can make is correlation. If you want to make a conclusion about causation, then you have to have an experimental or active study. But again, the experimental or active study requires a lot more time, effort, and money than the observational study. And that's why when you read in the news, now that we've talked about it, you'll see that just about every study that is made in order to report some kind of new conclusion to you, you'll see that it's going to be an observational study. You'll see that basically they're just observing things that have already happened, and they're making a conclusion based on that. But now you know that the best conclusion that can be made from that is correlation. Okay, so now that we've talked about that, let's look at another example. Let me leave this here.